Welcome to the deep dive. Today, we are strapping in for a high-speed tour of how artificial intelligence is really shaking things up.
Mhm.
Specifically, how it's being deployed directly on, well, one of our biggest challenges, the climate crisis.
Yeah, it's a critical area.
And look, this isn't just theory about what AI might do someday.
Sure.
We're digging deep into sources that show the real, measurable impact it's having right now on environmental
That's
efforts.
right. Our mission today is unpacking research focused on AI tools for environmental impact assessments and emission tracking. So the real practical stuff.
Exactly. And the shift we're seeing here is pretty huge. For years, figuring out your environmental footprint, whether you're a government or a company, it was slow, expensive, mostly manual.
And backward looking, right? Always based on old data, maybe some educated
Well,
guesses.
totally. It was retrospective.
Which is why this matters for you, listening in. AI is offering like a shortcut to being genuinely informed. It lets companies, governments, whoever, gauge their real-time impact, measure carbon reduction almost instantly.
So the core theme running through all this material is that transformation, isn't it? AI turning these slow reviews into efficient, predictive tools.
Precisely. Predictive is the key word there.
Okay, let's unpack this then. Let's start with what's often the biggest hurdle for any big project, the environmental impact assessment, the EIA.
Ah, yes, the EIA. Mandatory reports often take years, meant to figure out if a new project will wreck the local environment.
And traditionally that process is, well, it's a beast.
It really is. You're
Right.
pulling together massive, totally different data sets, geological surveys, how water flows, biodiversity counts, projected human activity. It's a lot.
Trying to model how all that interacts manually must be a nightmare.
Absolutely. And that's where AI just changes the game.
Our sources are really emphasizing this leap in accuracy, specifically using advanced AI like deep learning. Can you break down what deep learning actually does here? Why is it better than old models?
Sure. So deep learning models are incredibly good at spotting patterns in huge, messy data sets. Unstructured data. Think satellite images, sensor feeds, drone footage, even social media chatter about land use.
Stuff that isn't just numbers in a spreadsheet.
Exactly. So they're not just looking at average rainfall, they're synthesizing all of it. This lets them run way more complex, more nuanced simulations of what might happen before anyone even digs a hole.
So instead of one static best guess, it's like running thousands of what-if scenarios on the fly.
You got it. Thousands. And when you connect that to the bigger picture, the potential for error just shrinks dramatically.
Okay, so the big number here.
Yeah, the sources highlight this pretty starkly. AI can now predict the environmental impacts of new projects with, get this, 90% accuracy.
90%. Wow, that must completely change the risk calculation for everyone involved, developers, regulators.
It absolutely does.
How is that 90% measured, though? Is it just compared to older models or against real-world outcomes?
It's a mix. But mostly it's validated against historical data and then checked with real-world observations later on. The key is how detailed it is.
Right.
If the AI predicts, say, habitat loss will be X amount, and 2 years later drone surveys show it's actually 1.1X,
Yeah.
well, that model gets validated as highly accurate.
So that level of certainty, that 90%, it means regulators can put in protective measures they know are needed, not just guess based on worst-case scenarios.
Exactly. It takes a lot of the argument out of the equation.
Okay, so it's accurate. But you said earlier, it's not just about being right, it's about being fast. Compliance is always blamed for slowing things down.
Oh, definitely. Because gathering all that data, normalizing it, running those complex models, they used to take months of analysts' time. Weather, water flows, population shifts. AI just automates that whole data processing and correlation piece.
So what's the biggest time saver in that? Where does AI make the most difference?
It's really that initial data ingestion and synthesis. AI systems can take reports, PDFs, sensor feeds, satellite images all at once, understand them, and pull them into one coherent model almost instantly.
That alone must save weeks.
Easily. Weeks of human data prep just gone.
And the metric backs this up. Assessment times cut by 40%. That's huge.
40% faster. That means quicker approvals, faster deployment of needed infrastructure, like renewables or transport projects.
So the real implication here.
The implication is significant. Speed plus accuracy means you can be proactive. We shift from approving a project over 3 years and then finding the damage 5 years later.
Right, the reactive approach.
To adjusting plans before you start building. You basically guarantee better environmental protection and less regulatory hassle from the get-go.
That's the paradigm shift.
Right.
Prevention, not just reaction after the fact. Okay, so that covers the pre-approval side with EIA. What about pollution that's happening right now? Let's pivot to active monitoring.
Good transition.
Pinpointing pollution. AI isn't just predicting future damage, it's tracking emissions happening now.
Absolutely. The next big application is emission monitoring. These AI systems track the main offenders, CO2 and methane emissions, across different industries.
Methane tracking is really interesting, isn't it? Because it's trickier than CO2. Methane leaks can be sudden, quick, hard to locate with old methods. How does AI tackle that?
Yeah, methane's slippery. That's where advanced sensor integration is key. Old methods might give you a general sense of emissions over a large area.
Kind of a blurry picture.
Right. But AI uses satellite imagery tuned specifically for methane plumes, combines that with real-time pipeline pressure data from IoT sensors, and then layers on weather models.
So the AI acts like a super efficient detective, basically, narrowing down the search instantly.
Precisely. It pinpoints specific emission hotspots,
Right.
like exactly which valve is leaking or which smokestack or which bit of pipeline. Without AI doing that correlation, those quick methane bursts would often just be missed or blamed on the wrong source.
And finding the specific source means you can fix it immediately, target the repair.
Exactly. And the data shows this improves the quality of the monitoring itself.
Ah, so better data integrity.
Yes. The sources mention a significant drop in measurement errors compared to traditional methods, up to 25% fewer errors.
25%. That means regulators and companies can actually trust the numbers more, make better decisions.
Much more confidence in the data, absolutely.
Okay, here's where it gets really interesting, talking about the specific tech involved. You mentioned integrating lots of data streams, but what's the brain doing the synthesis? Because this isn't simple stuff.
No, it's not. And we're seeing a powerful convergence here. The source material explicitly mentions tools like Grok 3 from XAI being integrated into these environmental workflows.
Grok 3, that makes me think of large language models, for chat or coding. Why is an LLM useful for crunching environmental data?
That's a great question, and it highlights how tech gets adapted. An LMM here isn't writing poetry about pollution.
Right.
It's being used as a massive, super fast data correlator. Think about all those different inputs, numbers from sensors, text from maintenance reports, metadata from satellite images, weather forecasts. They're all different languages.
Okay.
The LLM can understand all these data languages, synthesize the complex relationships between them, and spot correlations that a normal database query would totally miss.
So it's like a hyper-efficient translator for data sources that normally don't talk to each other.
Exactly that, a translator and synthesizer. And these tools integrate smoothly with global data sources, especially IoT sensors, out in the field, giving those grainy, granular readings.
The rugged little devices sending back data.
Yep, and complex weather models.
Mm.
And the machine learning algorithms use that unified picture to optimize emission reduction strategies. It doesn't just tell you there's a problem. It suggests how to fix it.
Which leads us perfectly into the final piece, predictive power and global impact. It's not just tracking what's happening now, it's using that to see ahead.
Predictive analytics. That's the strategic endgame here. Analyzing past trends, current readings, other factors. AI forecasts future emission trends.
And that forecasting is crucial, right, for meeting climate goals.
Absolutely vital. It enables proactive, long-term strategies if, with that 90% accuracy we talked about, what your emissions profile will likely be in 2027. Well, you can start investing in the right abatement tech today.
This moves way beyond just ticking regulatory boxes. This changes how companies manage risk.
Fundamentally, it changes investment decisions. When you have high confidence in your environmental outcomes, the whole liability picture shifts.
Yeah.
Companies can put capital where the AI predicts the biggest bang for the buck in terms of reduction.
And we're seeing this adopted more widely now by governments, big corporations.
It's becoming standard practice surprisingly quickly. So what is the sheer potential scale?
Yeah.
Adoption is accelerating because the economic case for speed and accuracy is just becoming undeniable.
Which brings us to the biggest picture metric in our sources. What's the actual projected global impact if this keeps scaling up?
Well, there's a 2025 report with a forecast that's ambitious, but seems achievable. AI-driven EIA and monitoring could cut global industrial emissions by 10% by 2030.
10% globally by 2030.
10%. That's a massive contribution toward global net zero targets. And it's not just a hopeful number. It's based on those efficiency gains and proactive strategies that accurate, fast data enables.
Wow. A 10% cut in industrial emissions in, what, the next 5 or 6 years? That's huge. It really hammers home that this deep, fast knowledge is incredibly powerful when you apply it strategically.
Exactly. This kind of data fast, accurate, predictive allows for operational tweaks that just weren't possible before.
Yeah.
Proactive strategies starts to look like optimizing supply chains in real time to dodge high emission routes or adjusting power use based on immediate weather forecasts affecting renewables.
Or deploying carbon capture tech exactly when the AI calculates it'll be most effective.
Precisely. It becomes much more dynamic.
Okay, so let's synthesize the results of this deep dive for you, the listener. AI is bringing this powerful combo: 90% accuracy in prediction, the potential for a 10% cut in global industrial emissions by 2030, and doing it all while speeding up compliance by 40%.
Yeah, it turns compliance from just a slow hurdle into potentially a data-driven edge.
This knowledge really shifts the conversation.
It does. And if that barrier to quick, accurate environmental insight is effectively removed by AI, well, it makes you think about the ripple effects. So here's a final thought for you to mull over. If AI makes understanding and measuring ecological impact this easy, what other traditional industry practices, things beyond just compliance and emissions, might be next in line for rapid change because of this new speed of insight?
What does this all mean going forward? We'll let you think about that. Thanks for joining us for the deep dive.
Until next time.